Now before we start, what I've done here is started to draw a sketch for what we're given. So we've got this car of mass 1,000 kilograms, and you can see I've already marked in the weight mg, 1,000 g newtons. We've got this car then of mass 1,000 kilograms. It moves with a constant speed of v meters per second up a straight road inclined at an angle theta to the horizontal, where sine theta equals 1/30th. And we're told that the engine of the car is working at a rate of 12 kilowatts. That's the power then. And we're also told that the resistance to motion from non-gravitational forces has a magnitude of 500 newtons. So if the car's moving up the slope, we're going to have a resistance to motion acting down the slope. 500 newtons, we're told. Now we've got to find out what V is. Well, we need to add some more forces to this diagram. We've got the contact force from the slope, that acts perpendicular, so I'm just going to call that R newtons. We've also got the driving force from the engine that's developing this power here. So let's mark that in as the driving force D newtons. Okay, so they're the only forces acting on the car. So in the usual way, what I'd want to do is just draw a dotted line from here perpendicular to the plane. This angle in here would be the same as the angle of the plane, in this case theta. So how am I going to get V? Well, we should know that power equals the driving force, D in this case, times V, the speed. Power equals dV. But we don't know what D is, but we can get that by resolving up the plane using Newton's second law of motion. So that's the method that I'm going to use here. And at this stage you might want to pause the video if it's given you enough of a clue of how to do this from here on. So if you'd like to have a go, just pause the video and come back when ready, and I'll run through the solution. Okay, welcome back if you did attempt this from here. So I did say that we'll resolve up the plane first of all to find out what D is. So if we resolve up the plane, we've got all of D acts up the plane, so you've got D, then you've got the minus 500, all of that acts down the plane, and then you've got the component of the weight acting down the plane, which will be minus 1,000 g sine theta. So minus 1,000 g sine theta. So that's our resultant force up the plane, but that resultant force equals mass times acceleration, but because the acceleration is 0, it's moving at a constant speed, then obviously this has got to equal 0. Now you can rearrange this for D at this stage, so D will equal, and if we add 500 and 1,000 g sine theta to both sides, you're going to get D equals 500 plus 1,000 g. And if we take g to be 9.8, and then we've got sine theta, well that's going to be 1/30th, so pop that in there, 1/30th. And if you work this out, what you get is 2,480 over 3. Or you could have it as a decimal, and if you work it out as decimal, it's 826.6 recurring. So that's the driving force in newtons. Now we know that power, okay, as I mentioned earlier, power equals the driving force multiplied by the speed. And the power, we've got to make sure, is converted into watts. So if you've got 12 kilowatts, that's going to be 12,000 watts. And it equals the driving force, which we've just found, is 826.6 recurring times now V, the speed. So to get V, all we need to do is do 12,000 then divided by 826.6 recurring. And if you work that out, you find that you get 14.5 516, and so on. Which, if you round that up to say 3 significant figures, it's going to be 14.5. 14.5 meters per second to 3 significant figures. Okay, so I hope that's given you an idea then how to go about that.